Hello everyone, I am Aditya Kapadne. Hello everyone, I am Aditya Kapadne, and today I am going to do a presentation on the research paper named IoT-based wearable biomedical monitoring system. This paper is actually done by Swati Kale. So let's get started. Outline of this presentation consists of introduction, problem statement and objective, proposed methodology, system implementation, and conclusion. So let's get to the introduction. So what is the wearable sensors? So the sensors which are actually helpful for detecting various physiological parameters such as sugar level, temperature, then respiration rate, then pulse rate, position, motion, hydration, etc. are known as wearable sensors and which are used for biomedical purposes. The different type of sensors are used for different type of purposes, such as pressure sensor is used to measure the pressure, temperature is used to pulse rate sensor is used to detect the pulse rate, and so on. So these kind of sensors can be embedded into a system so that it can benefit the patient and which can reduce human effort. So that's the introduction of the system. So the problem statement is to design and create an IoT based wearable biomedical monitoring system, and the objective is to enable remote sensing of different physiological factors such as temperature, pulse rate, and body movement. So this is what we have in the proposed methodology. This is the block diagram of the basic system which they have implemented. So here the system comprises of temperature sensor, a pulse rate sensor, and acceleration sensor. These sensors are then interfaced to signal processing so that the signals transmitted from these sensors are amplified and they are processed in such a way that they are suitable for the computer to read. As these signals are analog, because these sorry, as these sensors are analog sensors and they give output in analog form, so then the computer needs to understand it, and hence it needs an analog to digital converter. So even they have provided the same. So they have provided three analog to digital converters for the three different sensors. Then these sensors are then sent to the multiplexer and then to the CPU. So this is what happens inside the microcontroller. So after these signals are being implemented in the system, then the system transmits these signals through a RF transmitter which has a 2.4 gigahertz frequency. So these systems work in a harmony with the receiver side, which comprises of a receiver, which is an RF receiver of 2.4 gigahertz. Then this receiver sends the signal to the CPU, and the CPU uses a demux to break down these signals into different forms. Then the signal broken down into three different aspects, such as the display for and alarm for temperature, then display an alarm for uh, temperature, and again display an alarm for temperature. So then these different kind of sensors, then these signals are then sent to the server using IoT. Now this server can be present for the doctor as well as the relatives for the patient, and the signals which are sent and the data which is processed is then sent to the alarm system to decide whether the condition of the patient is either critical or is stable. So this is how the system is kind to try to work. We even have a graphical display over here. I left it over there. I'm sorry. There is a graphical display which actually helps in determining what changes are taking place in real time. So these are the proposed requirement analysis, wherein they have used an Arduino Uno R3. Basically, this have an Atmega 328P microcontroller. Then they have used a pulse rate sensor, which is used to detect the heartbeats of the patient, the pulse of this patient. Then they have used a temperature sensor. For that purpose, they have used an LM35 sensor, which has three pins: VCC, output and ground. Then they have also used a MPU 6050 accelerometer for detecting the position of and movement of the patient. Then they have used an ESP32, sorry, ESP8266 module for transmission of all these signals into the system. And they have also Nokia 5110 graphical display to display all these signals and the data on the screen. And this is what they have done in the system implementation, wherein they have done all the necessary connection, and they have the system working on them, wherein it shows the temperature, it shows the x, y, and z coordinates of the system, and they also have the pulse of the patient. And then these parameters are then sent to cloud through IoT service, and these are then processed into graphical interface, so which produces the three different graphs for three different aspects. So these are the temperature, pulse rate, and motion sensing graph, which shows us the three different aspects. So coming to the conclusion, this design system provides low power consumption, less complex and portable band for healthcare monitoring system for patients. It can avoid the utilization of wide setup, and the system made less costly. The doctor can access the patient's information from any corner of the world using web server. In future, we can develop a GUI for the patients who are present in the ward, and for long distance consultation, web server is a useful approach. Also, minimize the size of the wristband. The parameters of patients are continuously monitored, and data is uploaded to the server. This server keeps that information in the database, and if any doctor wants their access to the old patient's history, then doctors can easily access that data. Thank you very much.